Alright, so taking a look at number 3, the directions are find the slope of the line through the given pair of points, if possible. Based on the slope, indicate whether the line through the points rises from left to right, falls from left to right, is horizontal, or is vertical. Now, before we go ahead and actually tackle what it is they're asking us to do with the given points here for number 3, let's go ahead and look and see what each of these descriptions visually means. So what does rises from left to right visually look like? What does falls from left to right visually look like? And what is horizontal and what is vertical? So if we're talking about a line that has a positive slope, that line is rising from left to right, because we always read graphs from left to right. So just like reading a book, we start at the left and we move right. So if we take a look here at this first example, this line starts lower, and as we read or move from the left to the right, and if I could not move the picture, as we move from left to right, this graph you can see is rising. It's going up. The x values are going up, the y values are going up, so this is a line that has a positive slope. Similarly, if we look at the next example here, the downhill slope, that line has a negative slope, and so we would say that this line falls from left to right. So again, we read a graph from left to right, so if we start and we look at this line, as we read the graph from left to right, our y's are getting smaller, and so this line is falling from left to right. Looking here at the horizontal example, this line has a slope of 0. And so an easy way to remember what kind of slope a horizontal line has is that you can easily make a z out of a horizontal line. A z for 0. And similarly, if we take a look at the vertical line, this line has an undefined slope. Again, an easy way to remember what kind of slope a vertical line has is we can make a u out of a vertical line. So we can go u, n, d, e, f, undefined. Or sometimes you'll say that a vertical line has no slope, so no slope. And again, you can easily create an n out of a vertical line, so no for no slope. All right, so using this information, let's go ahead and take a look at the two given points that we have here and see what kind of slope we're going to end up with. Is it going to be positive, meaning it rises from left to right? Is it going to be negative, meaning it falls from left to right? Is it going to have a 0 slope, meaning this line is horizontal? Or is it going to be a vertical line, meaning the slope is undefined or there is no slope? And so we have 2 points. We have 2, -5, and 3, 6. And let's go ahead and label these points. So let's go ahead and label this first set here as x1, y1, and this next set as x2, y2. And we want to go ahead and label these points because it will make it much easier to distinguish which points we're going to be using when we plug into the slope formula. And the way that we do that is we're going to go ahead and take these points and plug them into the slope formula, which is y2 minus y1 over x2 minus x1. And so if we have our points labeled, then we can easily take these points and plug them into this formula. So let's go ahead and do that. Let's go ahead and take a look, and here we have y2 labeled as 6. So we're going to have 6 minus y1, which we have as being -5. And it's important here, you'll notice that I plugged in using parentheses. And you want to do that because if you plug in without parentheses, there's a chance that you might make an arithmetic mistake when you go to actually evaluate the slope. So get into the habit, not only on this problem, but really going forward into the rest of this course and into higher level maths, whenever you plug in a value for something, go ahead and do it with parentheses, and it will help you to alleviate some mistakes when it comes to signs. All right, so we have our x1 minus our y1, and that's over x2 minus x1. And our x2 is labeled as 3 minus Our x1 is labeled as 2. All right, so now we have 6 minus a negative 5. Well, we know that when we distribute this negative to this negative 5, we end up with a plus. So we end up with really 6 plus 5 over 3 minus 2. And now evaluating finally, 6 plus 5, well, that gives us 11. 3 minus 2 gives us 1. And of course, 11 over 1 reduces to simply 11. So our slope here equals 11. Now, because our slope is positive, right? Positive, we can see here then, based on our visual examples here, that positive slopes are going to rise from left to right. So this is rise from left to right. This here is fall from left to right. And then, of course, we have horizontal and vertical. So since our slope was positive, our line is going to rise from left to right. And so let's go ahead and answer our question, make sure we did that, find the slope of the line. We did. Here's the slope. It's 11. And based on the slope, indicate whether the line through the points rises from left to right. All right, so let's go ahead and do that. So this line rises from left to right. All right, and there are the two pieces of our answer for number 3. I'll see you at question number 4.